inductive solution. But what we were trying to do, and here you see the egg and the new life that is born, because of course it's something completely different from what we were seeing before. We want total position freedom, which is impossible even with our inductive solutions. So you need a decent alignment of the coil with what I told you about a second ago. We want to be able to charge simultaneously and independently every kind of device, small, medium, large-sized devices. We want efficiency, so we want an efficiency comparable with, once again, a traditional power adapter, corded power adapter. We don't want to compare our solution with wireless, but with the adapters. Why? Because we are trying to create a new market. We want something very thick. Why? Because we have seen with our customers that the capability to create thin designs is crucial. Several times with induction, they were asking to reduce the performance and to have a huge impact on efficiency because of the need for thin devices. And we want something which is cost effective. So going from the cost of a charging spot to a cost of a square feet of charging area. So something like this. And this is what we achieved with our Eden technology. I would like to show you a video, which probably you have already seen. Oh God. Let's see if it works. Yes. Okay, so this TV is supplied wirelessly since 2017, so it's incredibly reliable. It was not done for reliability, but it's reliable. Total position freedom, you can see that there is not a battery inside. We are transferring 150 watts wirelessly with a peak over 230, something like this. And you can see that you can move over a large surface without any issue. Now, let's try to understand more about how this is done. This overpower, this is another key point of our technology. As we have a high-pass filter, because these are capacitors, high-pass filters, we can also transfer data. And what I was going to show, but you can see from the picture and the preview of the video, is that on the same surface we are able to transfer data as if we have a USB connection. You may wonder, yes, but now we have 5G and we have several other ways to transfer data, and this is absolutely okay. Here the idea is to have something local so that it's the security of the solution is intrinsic, and we want the same speed of a USB 3 cable, so being able to transfer 8K video in seconds. So this is the goal. Why? Because the bandwidth is the same. So we can achieve that. We have already working centers and also customers using data over power, in particular in the field of tractors, vehicles, and so on. They want power and they want data with a bidirectional flow. And this is together with the same power channel. Now, let's start seeing how it works. Very easy. You have very thin layers. I can show you later some samples of these layers, but think about a flexible PCB, so something literally with no cost. The receiver is bigger than the transmission pad, so you can think about this laptop or any of your smartphone. That is the size of the receiver. And you can have receiver with different sizes, as you can see from the rendering there. Then what you have is that the transmission layer is made of a large number of small pads. And each of these small pads has an ASIC which is super low cost, and you will understand why it's very cheap. By contrast, all the complexity is put on the receiving side. Let's take a look at the transmission surface. You can see that each pad has this hexagonal shape, And it's divided into 6 triangles, and each hexagon is controlled by a single chip. Now let's try to understand something more about the circuit. Okay, don't be worried, it's not very complicated. You have a signal that comes from the secondary side. It's a 2.4 gigahertz modulator. It's injected into the receiving pads, passes through the transmission pads. What transmission pads? Just the ones which are covered by a receiving device. So, for example, here in this area, you have the receiver, the laptop, that is injected in a signal here, but not here. So the surface not covered by any device is completely turned off. By contrast, the surface which is covered by a device is turned on. Why? Because we demodulate the signal. There are thresholds in order to activate a different number of subcells for each cell, and this is how we do the regulation. And then we start the transmission of power, which is at 13.56 megahertz. The receiver is made with quadrupoles. Why? Because like this we don't have any emission. There are several reasons why EMI with capacitive technology are extremely good. One is because the electric field is confined. Secondly, because whatever is missing, it can still be cancelled with this approach. And so at the end, we were able to certify the devices very easily in comparison with our activities in the inductive field. And here are some results, which all these are working demos, and also something in this range of power is in mass production for a vehicle. With data, so not only power, but data over power. Here you can see 10 watts transmitted through 12 picofarads. Here we have a laptop and a transmission of 100 watts. And here we have a smartwatch with, that was the most complicated one. Some early adopters with solutions that are mainly today in the industrial field. Of course, our next goal is to start something in the consumer market, because we see this as a potential way to create a standard that covers all the kind of consumer devices from tens to hundreds of watts easily. So this is more or less what we do. We are working to find an ecosystem, which is one of the reasons why we are here. So this is the end of my presentation, and I'm glad to listen to your questions.
Yeah, we'll take some questions. Questions for Igor?
What's the maximum power you can transfer by a capacitive power transfer by the Eden solution?
So what amount of power?
What is the maximum power?
There is not a maximum. It really depends on the area. In terms of power density, it's similar to inductive solutions. Of course, then it's all relative. So how much area do you have? What's the distance? What's the frequency? Right now we are working at 13.56 megahertz, which is very, very nice frequency because of all the compromises that we had to do. But then for specific application, of course, it really depends. So if you want 10 kilowatts for a car, I will reply, pretty complicated, okay? But if you ask me 1 kilowatt for home, I don't know, kitchen equipment or something like this, maybe the answer is that it's possible, but we have to see the conditions. So where the surface is placed, how it's done, and so on.
Okay, and what is the area, like typically, which you use?
The
area over which you transfer the energy.
See the
air gap.
Air gap, 5 millimeters.
Okay, can you increase it?
Yes. We also did 10 millimeters with lower level of power. So really depends. More area, more air gap. Yes. If you want 4 centimeters or so, we usually provide the inductive solutions.
Okay, thank you.
Yeah.
I think another question. Yes.
At one point, of course, we literally tell the customers low distance capacity, higher distance inductive. This is the very easy way to select the right technology.
Igor, thank you, very nice presentation. I'm Kurmafidi from Cornell University. I also work in past core transfer. My question was going to be, how do you see this community developing? Because obviously inductive has been around for a long time and there are standards around it. And so what's the pathway for capacitive to create a community and start creating standards?
Of course, first of all, I love the fact that you are also working on that. So I feel that we must start building a standard. So saying what are the 4, 5, 10 devices that we want to charge? What are the rules that we want to put there so that we decide and agree that this is the frequency, and for these reasons, this is how to build the communication. We have a way, our own way, but we are open to discuss. So the rules of the game in order to create a community, because of course induction was pretty successful because of the standardization. Otherwise we will do, as we are doing, a lot of single solutions, which may be good to start, but good for the industry, not good for the volumes, and not good for integration, which at the end is our job. We do chips, and so we want to sell chips in tens of millions of units. So.
Other questions? All right. Thanks so much, Igor. That was great.
You must be aware that NFC forum uses 13.56 and solutions are around 1, maximum 2 watts.
Yeah.
And here you're talking about power no limit.
Yeah.
I don't want to say the secret behind it, but what is it that you're doing different where you can really get high power from 13.56? Very briefly.
Well, the different approach to transfer, the kind of coupling is the physics behind it. So that is the reason, the physics behind the capacity. When you are there in proximity, it's very efficient and works extremely well. If you go lower with frequency, I reply the opposite. So I tell you, it doesn't work at all. So that range is more or less where you see a crossover between induction and capacitor. Okay? So if you take a look at the parasitics, relative parasitics is what I call it, you will see that the relative parasitics of capacitive approach are smaller in comparison with induction at that frequency, of course, at that frequency. And this helped us a lot to rise the efficiency. What I haven't told you is that the 2017 TV demo was 85% efficient. And an adapter is 88 usually. A good adapter can be 92, 94, and so on. And today we did the demos at 92% efficiency. So that is the reason why you can be so efficient with these constraints very clear in your mind. Okay.
That's good. Thank you. Awesome.
Thanks so much, Igor. That was great. Oh, while Gordon plugs in, I'll introduce him quickly. So Gordon Bell is with Energous. He has more than 25 years of experience in technology marketing, ranging from brand creation to investor relations and corporate communications. He's currently the VP of Marketing at Energous. As most of you know, they're a leading developer of radio frequency-based charging technology for wireless power networks. Gordon also is on the board of Airfuel Alliance, and he's going to share about Energous' technology, Watt Up. So,
okay, thank you. I've spoken to some of you outside, and of course, if I go over anything on presentations today, any questions about that, maybe you're too shy to raise your hand at the end, just come see me. I'm right outside the door. Before I get started, I'm just curious if I raise your hands. Who here has heard of Energous before? Okay, I got some more marketing wise, so not everybody, but yes, it's good to see that. I'm going to give a little quick background. We're talking about our tagline lately is unleashing the full potential of IoT through wireless power networks, and why that's important and how that works. We see IoT deployments today, purpose-built workstations, tablets, kiosks, where we have these different devices that are connected to the cloud, and some limited in consumer stuff. But we see a change in that as we move along. And what that is we believe our technology allows for an augmentation of IoT. And the reason why is because we can either power battery-less devices and energize them, like we do with partner Wiliot. And we can also allow for enhanced features for devices that are currently on the market that are looking towards the next generation. So for instance, electronic shelf labels. Right now they're fairly static, where they provide primarily just pricing information to you. What they want to really extend their capabilities to actually communicate and engage customers as they walk through the retail store. All those different new powerful features they want to add, unfortunately, require more power and more battery use or more frequent battery changing. And those things are problematic for deployment. What we do is we have a technology, it's silicon-based, and we have a technology that can be embedded into Wi-Fi type routers, as well as standalone devices, that allows for the energizing or powering of devices over the air. So not conductive, not inductive, but actually over the air using RF. We have silicon for receive as well as transmit, including power management IC. This is a standard block diagram for how our transmitters and receivers use Bluetooth to communicate, and they use 915 megahertz to transfer the power. It might be hard to see from the back, so I'll jump over that, but once again, if you have questions, let's talk. I really want to get into how you'll see this technology come to the market. Tristan mentioned we are very proud members of Airfuel Alliance. They are leading the standard for wireless power at a distance, and we're excited. I think we'll see some announcements over the next few months as we move along to see that standard come to market. Our technology is certified in the largest markets, US and Canada, the EU, China, and India. There's still a few markets that are very important for us to continue to work towards, and hopefully we'll see some announcements for those. But this is a very large amount of potential applications in these markets for us. Our focus areas, if you come outside and take a look at some of the things that we're showing, end-to-end device tracking, so RF tags. We partnered with a company called Wiliot a few months back. We announced that partnership. There's other companies like that where they have a battery-less device that they are looking to embed into not only packaging like produce and so forth at the store, but also all other sides of retail, whether you're buying clothes or buying different things at the store. Being able to identify things and behaviors by consumers is very important, as well as from a food standpoint, food safety, being able to identify humidity, temperature, all these things that are important for raw and natural foods. The other focus area for us is electronic shelf labels. If you're familiar with that, it's very popular here in Europe. It's starting to take some traction in the US, but the electronic shelf labels, the issue with them is that they need battery replacement. Their batteries can last a couple of years, but that's at its current state, where they're really kind of just showing you a price and changing from time to time. But as they want to introduce new features, that battery life is drastically reduced. And as they add new features, that becomes a bigger issue. So ESLs and RF tags are our main focus areas. These are the market opportunities you'll see from a dollar amount to it's a huge market. Smart home, discrete manufacturing, retail, and healthcare. From healthcare, asset tracking, whether that's devices, medications, as well as even patient trackers. Unfortunately, there's issues where patients may wander off, and they want to identify where they are at. Believe it or not, that's an issue for healthcare, as well as vaccinations, drugs, door sensors, etc. Retail, we mentioned a little bit about that. They want to be able to identify what's the most popular area of the store. Where are people spending time, the dwell time? What's the most popular products that they're taking off the shelf? Are they trying on these shirts and not buying them? Or are they trying them on and going and purchasing? Are they trying maybe a size medium on and they go and purchase a large because the sizing may be a little bit inconsistent with other stores? All those different things are trying to improve the experience for the customers. Discrete manufacturing robotics is a huge level of interest for that, where we want to get rid of all the power cables for robots. But then you also have all the different sensors, from keep-out zones for human workers to sensors who are regarding air quality, temperature, and other items. And then smart home, that's what a lot of people are excited to talk about. Smart home is something that's very interesting as well. Being able to power devices wirelessly through the air. As you look at retail deployment, transmitters, particularly the mesh network for limited coverage area, there's different things that are going to be part of our experience as you go through the store, whether it's security, there's AI, there's stock, out of stock alerts, as I mentioned, ESL, they want to track temperatures throughout. All those different things either require cords, which makes it fairly restrictive in terms of how they can set up the store and how they can move around the store. And then if they're not using cords, they're using batteries. And our technology and technologies like them with wireless power, the key is being able to be mobility free from issues. From industrial deployment, air quality, temperatures, those types of things, very similar. You'll start to see that these devices come into play much more than you might be thinking about from the regular standpoint. Double check here. And then healthcare, asset tracking, temperature, air quality, secure storage, patient tracking. With that, it gets a little boring for me to keep talking about the same stuff over and over again. I tend to go fairly quickly. I do want to kind of get questions from the audience, whether it's questions specifically about our technology, our company. If we can, if the little microphone person is out there. Oops. Okay, here he goes. So questions. I'd love to get some questions from the audience. Just raise your hand and we'll come over. Yep.
Hi, Mark. I have one.
Okay.
Can everyone hear? For a situation like a warehouse, over what range are you really targeting for a single transmitter, or is it 10 meters? Are you creating beams for each tag, and you're periodically revisiting them, or is it always on?
Yeah, so that's a great question. I've had quite a few questions this week about are we doing beamforming or are we broadcasting? When the company first started, we talked about beamforming and we talked about 5.8 gigahertz as a frequency. We pivoted away from that. So beamforming, what we saw was there's issues with pricing. Costs, the BOM costs are very high for beamforming because you have power management IC and controls for every beam. And then also size, especially in the consumer market, size for beamforming becomes problematic. In the case of industrial, it depends on if it's an autonomous location. If it's autonomous for robots and so forth, we can turn power up almost to a level that's an area that is autonomous, it's fine. When you're talking about a warehouse or something where there's human presence, we typically have a mesh network where you have multiple transmitters that kind of mesh together, and it could be anywhere from 10, 20 meters apart, depending on the sensors that we're engaging with. A lot of times there's sensors that are fairly high up, and we want to either be able to have a transmitting power going up to that. The other thing to note too is we're seeing interest not for necessarily just standalone transmitters, but transmitters that can be embedded into things. So for instance, transmitters that might have be embedded into actual retail shelves, where in a typical aisle, there's a shelf on both sides, and one shelf is sending power to the other shelf and vice versa. So we're keeping it kind of close. And one of the other things I didn't really talk about is not only sending power, but we're actually collecting data. So in the case of the Lilia tag, we're energizing these little Bluetooth tags, and we actually receive data from them and send it back into the cloud. They typically are a little too far away from AP, so they're not able to send power all the way there by themselves, but we can aggregate all that data and send it over. Yep, that's a question.
Sure. My question is kind of related, but maybe I'll give a little different spin. So yesterday, or day before, we had this talk by Ali Hazimiri, who talked about sort of also RF power delivery, but they were lighting up light bulbs, which I presume is appreciably more power than the kind of applications you have here. So I was just wondering whether the reason they were able to do much higher power, was it because they're just using a different type of approach, or is it that they're not worried about regulatory stuff yet and will eventually hit that ceiling?
Yeah. Lighting up light bulbs is one of the things that I think, I believe that's one of the requirements at MIT, where they have a requirement for you in certain majors, if you're in this space. One of the ideas is you light a light bulb. Depending on the light bulb, it's actually not a lot of power typically, but lighting up a light bulb or doing different things in the lab is fairly easy. You turn power up, and you can send as much power as you want in some cases. But making a technology that is going to be regulatory approved from a safety standpoint as well as coexistence standpoint. So there's reasons why we are not trying to do certain things from an amount of power. We don't send a huge amount of power because although it makes a fun demo and we can do something cool like have a drone flying around the room or just hovering, it's just something that might not ever come out to the market because of regulatory. So yeah. I hope that answers the question.
If you could just explain the regulator, because I think your CEO spoke a little bit about it, which was that or somebody spoke about it, which was that the power times the gain needs to be under 4 watts or some number like that from FCC, at least in the US. But what exactly is the regulatory requirement?
So regulatory is definitely changing and evolving. When we actually came out, there were really no sort of test plans, right? If you and I started a company and we wanted to sell a Wi-Fi router, we can go get Wi-Fi chips, get a cool plastic design put together, and we would go to Underwriters Lab or someone like that, get our product tested. We could be on the market within a month because all that stuff already exists, all the testing and everything. But wireless power transfer, no, that didn't exist. So we actually worked with the FCC for about 18 months to identify how our technology works and how they can actually test it and how they can test it not just for us, but also for the other companies that are in this space. That's taking some time, and you're starting to see. We just announced approval for China, I think maybe a month, 2 months back, and we have approvals in various levels. So 1 watt for US, Canada, European Union, China, and India. We have 5 watts in some other countries as well as the US. I think you'll see some developments on that as we go along.
And is this 1 watt and 5 watt sort of total power radiated from your transmitter?
That's transmitted, conductive power.
Sent out.
Correct.
And it's independent of what your antenna gains, maybe your...
There is, and so you have Part 15 and you have Part 18 from the FCC, right? So Part 15 is a 1 watt max, and that's why companies like PowerCast and others have always done Part 15 because they are slightly under 1 watt. Part 18, you really have there's no limitation of wattage, but where they kind of limit you is the SAR level, right? So specific absorption rate, right? So what the amount of absorption by the human body in that application, right? So if you're in an autonomous warehouse, that doesn't become an issue. I was talking to somebody a little bit earlier today, there's companies that want to have drones every quarter mile or every mile on top of what looks like a telephone pole along these 1,000-mile pipelines, right? Because they don't want to have to drive out to that, and sometimes the landscape's too rugged for that. But how do they get power to those drones, right? So they can easily have something that sends power to the drone. The drone kind of sits in a, for lack of a better word, a nest on top of these telephone poles, and as needed, they jump off that pole and they go to the sensor fault, identify the issues, take video back to the team, and then it retrieves back to the nest, right? And it sends power over the air. There's no connections. It's fully waterproof, all that kind of stuff. In that situation, you can send a lot more. So it really depends on country, application. Is it something that's going to be around humans or not? There's keep out zones, just like a Wi-Fi router. There's keep out zone of 20 to 30 centimeters for a Wi-Fi router. Okay, other questions? Anyone else? Yep.
Thanks, Gregor. It's looking great. Actually, the question regarding the frequencies and also regarding the transmitter and receiver for this different application should be in some places maybe you can fix it, but some places is not fixed. So how you to consider the range, because it's affected on the range, it depends on the direction of the antenna. So for receiver and transmitter, so what's the sensitivity of the work that we and respect to the distance?
So it's all application independent, right? And the one thing is, if you come up to what we're showing on the table, we have a transmitter there. And we actually sell transmitters as part of our developer kits, but we are not in the market of building and selling transmitters. That's not who we are. You might see that transmitter technology coming out by companies that already make Wi-Fi routers or power routers, for instance. But it really depends on what the application is and how, we talked about perhaps a consumer device that looks like an Alexa type speaker, and it has antennas all around, and you just place your different devices kind of close to it. Small devices can energize from that. You can place your device on top of it for more of what we call near field charge. So although we're not focused on that, that's something that we see down the road coming.
My question is regarding far field. What about the far field, the maximum, the distance and what the sensitivity can mean in terms of the power you are going to transmit?
Maximum distance, it becomes, it's the chicken and egg. Okay, I send power, I send 5 watts perhaps. How far away are you? What's the angle? How big is the antenna? Is the antenna, 1 inch by 1 inch, or is it, a very large antenna? It really depends, but our typical applications that we're looking at, we're seeing those applications in the range of, I would say probably 5 meters max right now, and expanding depending, but 5 meters distance.
Okay, what about the self-power? Assuming you want just the wireless and the transmitted, send it by wireless.
Right, so the issue is that sending power, we send power at, let's say, 5 watts, and then we receive power. If I give you a number that's kind of middle of the road, typically we're seeing 20, 30 milliwatts in some cases. For instance, the demo that we gave at CES, I think we were 5 meters away from the ESLs, and those ESLs were receiving 50 to 100 milliwatts, right? That's can be improved by the angles, that can be improved by sending out more power, that can be improved by larger antennas, all those different things.
Okay, thanks.
Okay, other questions? Yeah? Ramesh?
I have a good presentation here, good clarity on what we have at the moment. I'm seeing different countries having different regulatory approvals, or they're coming in with practices, so that would go to religious on that. My question is, suppose we are approaching applications like IoT sensors, it's a global application. So if I want to install those sensors by different companies, same company but in different regions, do we need to tweak that product to the regulatory specifications of every country, or you think most of them are really standardized?
Yeah, so that's one of the reasons why we were looking and kind of settled in on the 915 range that gives us, we believe, to be the broadest appeal and the broadest approval rate, but we're not stuck at 915. We can actually change that based on countries. There's a few countries we might step out of that for, but not that it's supported by our technology. But there's also companies that are doing 2.4 and 5.8, and we see the big problem with that is we're gonna run into a lot of resistance when we come to Wi-Fi. Wi-Fi alliance groups are not gonna allow that, in our opinion, and that's one of the major reasons we stepped away from 5.8.
Would the next one be Japan and Korea, I guess?
Hard to say. I think Japan, Korea is obviously a very strong market for electronic devices. It's definitely on our radar.
Thank you.
So you're stepping away from 5.8, is it because of the Wi-Fi coexistence problem?
5.8, I think the bigger issue is Wi-Fi. Like I said, although it works fine in the lab, and there's other things that we stepped away from from 5.8, not just for Wi-Fi, but I think that's one of the biggest things. And as you'll see, Wi-Fi Alliance and things of Wi-Fi.
So is there any target frequency that you are looking for?
Say that again?
Is there any target frequencies that you are looking at?
So our frequency that we use is 950, and the bandwidth around those.
At the 915, you get a bigger size on the mesh antenna, right?
Yes.
One last question, if anyone has one? Not, we'll conclude.
Okay.
Great.
Thank you.
All right, very happy to introduce Dr. Morris Kessler from Witricity. He's going to share a little bit more depth, kind of about the trend he's been discussing at some other wireless power week events, really heavily focused on wireless charging for electric vehicles and where that section of the industry is going.
Yeah.
Oh,
Just took a little while. All right, thank you. Thank you all for hanging around. It's been a long week, but there's a lot of, I was excited to see all the work that's going on in the field. And today, I'm going to talk a little bit about what Witricity is doing and what our focus is. A little bit about the company. I said some of this the other night, but we're based in just outside of Boston, Massachusetts, but we have offices around the country. We're 80 plus employees at this point and growing. We've been in this wireless power space for 15 years, and so we've developed a lot of technology and a lot of IP in this space, and we've licensed that technology to a number of companies around the world for various different applications. But our internal focus right now that we spend our time on, engineering and R&D, is mostly in the space of transportation and electric vehicles. Because we do know that the number of electric vehicles is growing quickly, not only cars, but trucks and buses and personal mobility and things like that. And the question of how we're going to charge those is being looked at by a lot of people. And as Igor said, for the wireless power space, the competition is really the cord. It's not some other wireless technology. It's really about, or how you do the wireless, it's really the cord. If somebody can plug in and it's cheap enough, then they're going to do that. So, but there are some problems that we're all aware of. We're all in wireless power, so that's our goal here, is to get rid of those cords. So there are a number of advantages that wireless charging brings to this particular application. You can charge just as fast as you can plugging in. As I mentioned, most of charging, 80 to 90% of it, occurs at level 2, sort of 10 kilowatts and below charge rates. You hear a lot about DC fast charging and people doing 150 or 300 kilowatts on a DC fast charger. Those have their place, but those are really only needed for longer distance driving, where you want to be able to fill up as quickly as possible. But that's not how the vast majority of charging is going to be done. And it offers the ability to charge just as efficiently, really, as plugging in. A lot of people don't believe that, but if you look at what goes into a conductive charger, you have a lot of stages of power conversion. Wireless charger has a similar number of stages of power conversion. You've just got this air gap transformer sort of in the middle there, and that can be very efficient if you've done that correctly. So you've got a bunch of stages, but they're all 98, 99% efficient, so end-to-end efficiency can be just as good as plugging in. And the real advantage is you can offer the ability to just park your car, have it charged. You don't even have to think about it anymore. Today, with a gasoline-powered car, we're in the habit of going somewhere just fueling up. But in the future, with an EV, or maybe you even have one today, you won't have to do that. You only maybe when you're going to make a long-distance trip, you have to plan it out. But in your day-to-day, if you have wireless charging around, then it's getting charged every time you park. So it'll be ready to go. The technology is naturally bidirectional. So if you've built your system to be able to do that, it's naturally ready to go. So you can take this big battery that's on your vehicle, you can send that power back to the grid in times of high demand to make money, or you can power your home in case of an emergency, or if you've got a battery, a home power system that you can charge that up as well. And when autonomy comes into play, you really need some automatic way of charging. There's not going to be somebody there to plug in. The second key thing is that many people haven't heard of wireless charging, wireless power transfer. Those of you in the industry or in studying this, you think everybody knows about this stuff, but you find out that the vast majority of people don't even know that's an option. But when you ask them, is this something you want? They say yes. And so, over some other popular options in cars, like parking assist and things like that. So consumers want it. That's the second thing. And the third thing that people have talked about are required for some of these, and it was mentioned standards before, but we spent a decade getting standards in place because automakers want to make sure that their vehicle, if they put this on their vehicle, they want their customers to be able to charge at multiple spots, not just on the one that they might be able to buy with their car. So in the US, there was SAE had a standard, J2954, published a couple of years ago now almost. And as well as in Europe with the IEC and ISO, they each have standards, and they're largely compatible with each other. So you can have a car that you can develop a car or develop a wireless charging system that can work in the US, it can work in Europe, it can work in China. There may be some communication differences, so maybe there's a firmware update needed between those, but from a power transfer point of view, they're compatible. And so the things that have been standardized, it's frequency of operation, so that's critical, sort of interoperability requirements, how you will test a system to show that it's compatible with the standard, and the power classes and sort of ground clearance ranges. Those are the main things that are in there, along with safety requirements. So now the first automakers are starting to introduce this. BMW had a trial in 2018 on one of their cars, and now there are some automakers that are offering it in certain markets. So Hongqi, FAW has a car, Hongqi in China. It's a very high-end car that has autonomous parking as well as charging. I'll show you a video of that. Hyundai in Korea has released a model of the GV60 that has wireless charging for some trials there. And McLaren has it on a, if you've got a spare 2 million around on a McLaren Speedtail, that has wireless charging. That doesn't actually have a plug. It's only got wireless charging. It's a bit of a hybrid though. And coming up later is a car in China from Jiji. Now let's see if I can, so this, I have a couple of videos that I'll just show. This is the Hyundai GV60. This is, let's see if it's going to play. Oh well, maybe it won't play. It doesn't appear to be. Well, I'll just explain a little bit about their industrial design. So the components of a system, you know, the electronics that convert what's coming out of the wall into the 85 kilohertz that's used for power transfer. That's usually in a wall box, but it might be partitioned differently, with some of it maybe on the ground with the pad. But here, they had a certain industrial design. The electronics in this are not nearly this big, but they wanted this look because they're putting in some charging stations that have DC fast charging along with wireless charging. But that's what their system looks like, so I don't think these videos are playing, so let's just go on. Oh, now it's playing. So this is just at a motor show where they introduced this. And this is one of the locations where they've installed this. This is what the charging station looks like. There's the ground pad, the electronics are over here. The car, you know, it works in all weather, works through snow. It's been through a lot of testing, been through the full validation by Hyundai. The person is parking. There's some indication internally that, yes, you're parked in the right spot. You turn the car off and it starts charging. There's some, let's go, and this is the FAW vehicle at a parking garage in China where they've installed, you see a couple of systems there. This car is going to, there's no driver here, it's going to do auto parking. And you be careful with autonomy, I guess, right? You don't do that quickly. And as the car backs in, you'll get to see there's a much smaller wall box mounted on the wall than in the HMC. This system is essentially compatible with the China-based standards. The system from Hyundai is offering is compatible with really the SAE standards, but these two can interoperate with each other. And these were basically our designs that are in these. So now there's a wall box, yeah, that flashing green light there that has all the electronics that are connected to the grid, and now it's already charging. So that is an automatic parking charge. So automakers are introducing it, but the product cycle is very long for an automobile. It's a 5-year design cycle, not like a cell phone or something, which they refresh every 6 months to a year. So it's a much longer process. So in the meantime, we have put essentially this same system that was on that FAW vehicle. There's a wall box, a ground pad, and the vehicle pad is in this middle picture there. It's not a overall picture, but the vehicle pad's only about this big, and everything's inside there. The coil, the electronics, everything, and the DC voltage comes out, and that's what connects to the battery. And there's some connections for talking to the vehicle, because the vehicle has to tell the system how much power it wants, and that's the control. Their vehicle's always in control. So we've developed this upgrade kit that we're going to be applying to a few vehicles. We announced that earlier this year. This is just a
This is an ordinary 2018 Tesla Model 3. But you're about to see it do something that looks quite extraordinary. Isn't that amazing? Wait, what? You didn't see anything amazing? That is Electricity's wireless charging solution. So what you're seeing here is this Tesla is charging wirelessly, just as fast as the plug, but with no cords, no cables, no hassle. Extraordinary.
So that will be coming, but it's not just vehicles. There are other autonomous vehicles that wireless charging is going on to in the industrial space. But as autonomy develops, then this is a perfect fit for keeping those autonomous vehicles charged so that they can operate as long as they need to without having anyone there. As I mentioned, it's not just in the passenger vehicles. There's also a lot of work in wireless charging for buses and trucks. And in this case, it's not a question of, hey, this is a convenience factor for these companies, but it actually saves them money because trucks, here is an example of a loading dock where trucks are going to be sitting for some period of time. With charging, they can get their wireless charging, they can get their battery topped off so they can extend their lifetime during the day, the amount of miles they can be delivering things during the day. So that actually ends up being a cost savings. And it's not only just for this particular application, but in charging depots, you're able to more closely pack the vehicles together, which you can't really do with with conductive charging infrastructure. And some of you may have heard that Siemens recently invested in Electricity with a collaboration agreement, and it's really indicative that the technology is really there for being implemented. So it's just it helps us as a small company. A lot of times car makers, they look at a small 80-person company, they say, I'm not going to trust you to deliver what you say you are, but they'll trust a company like this to deliver. So this is a big help for us in that regard, and a big help for moving wireless power forward. As I mentioned, it goes beyond EVs, and there are many large companies that are invested and interested in this technology. They've taken licenses and are going to be putting it in their products in a number of areas. So with that, I'm happy to answer any questions.
Questions from Morris?
Morris, very good one. Thank you very much. Question is, you talked about efficiency and you said it's around 90% plus or even very close to the wired. And I know there's a trend towards, there's ambitious to use vehicle to grid or vehicle to home. And you mentioned about bi-directional charging as well. So any idea what the efficiency level is there? It could be much lower, I can guess, but...
No, it's essentially the same. So the wireless piece is the same. It can be, because the coil losses are going to end up being the same. So it's really a question of the electronics and sort of the impedance matching. So you design a system typically to send power in one direction. So when it's a bidirectional system, you have to also consider what it looks like going in the other direction from an electronics point of view. We've done that. We've demonstrated basically comparable efficiencies in both directions. So there's no reason it won't be that way.
And one question on reliability is about, obviously we're using industry standard and all. So the fire and all those things are possibly less to be occurring. But I know one of the reasons why wireless power was not adopted by OEMs was about the liability issues in case the car gets fired because of battery overloading and all. So where does the liability come into picture? Is it the OEM or is it the solution provider wireless charging or is it both? In general,
So make sure I understand your question. It was a question of where liability?
Yeah, in case there's a fire because of the battery overload or whatever.
Well, I mean, the car, when it looks at our system, looks like just a DC voltage supply, right? So we're not the cause of that battery fire. So it's no different than with any other onboard charger, for example, plugged into the wall. So that's a car maker, that's a battery issue, not a charger issue. They have to control, what goes in and how fast they charge the individual cells and all of that, so.
Thank you.
More questions?
Thank you, Morris, for the presentation. It was very interesting. My question is about the power level. Is electricity targeting higher power for light-duty vehicles? And if so, what's the power level you're going for in the next 5 years? For example, once for light-duty, and I also saw you working towards heavy-duty, and what's the power level there for the near future?
Good question, that maybe I failed to mention. So for light-duty vehicles, the standard really set power levels at like 3.3, 7, 11 kilowatts. So 11 is about the maximum that you can get from any home, typically. In Europe, maybe it's 10. In the US, you can get a little more than that, but not much more. In different places in the world, it's even lower than that. And if you look at the use case, you really don't need more than that in a place where the car is going to be for any period of time. I have heard some car companies asking for 22 kilowatts, for passenger vehicles, but I think that's more of a, hey, I want to one-up the other guy. And when they really investigate, you could definitely do that. It makes things a little bit bigger and more expensive, and so that's one of the barriers that you have to get through, is get it to a cost point where it makes sense to put it on a low-cost vehicle, and that's one of the main things that we focus on now. In terms of heavy-duty vehicles, that starts anywhere from 25 and up, so 50, 75. We heard a presentation this morning where they did 850, or that wasn't a product obviously, but there are people that are targeting sort of megawatt levels. Sometimes that's done via modules, so maybe you have a 75 kilowatt system that you can just parallel to scale that up. So depending on the particular application, 75 might be fine, even 50 for delivery vehicles and things like that. So it's all a use case dependent that number.
One more question? Go ahead.
I've been seeing that electricity have been working on consumer electronics under 30 watts, and now I see that your company webpage is covered with EV charging.
Yes.
So is it your strategically looking over to EV charging?
So we've had various applications going in parallel for a number of years. We did a consumer laptop charger, for a Dell laptop at 30 watts several years ago. But there was more pull from the EV industry than the consumer industry at the time. And so as a small company, we couldn't continue to sort of push forward and go. It didn't make sense from a business point of view to try to push everything in parallel. So the pull was coming from the EV market, so we switched over, and we have our licensees and partners that are addressing some of the consumer electronics space. So we still have, we still help people there for those applications, but our sort of internal effort is more geared toward the EV space.
One more?
Thanks, Morris. I was really interested in your retrofit systems.
Do you have any idea how much how much it will cost?
So the question is on the cost
Of the retrofit system, yeah.
of the reference system.
Retrofit.
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 Yeah.
Oh, we haven't announced that yet, so,
Okay.
yeah. Sorry, I can't give any information on that one.
All right, great. Thank you so much, Morris. Wiggle was supposed to be here with us today. As some of you who were at Wednesday night's event already know, their CEO had an emergency and was not able to attend. So I just wanted to briefly share what they're doing and remind you to maybe hit their website at wiggle.com and learn more. They're advancing technology that turns AC power into a wireless power mesh grid that targets and powers a wide range of devices, everything from security systems and drones to home electronics, laptops, phones. They're hardware agnostic, so they're actually utilizing partners to deploy their touchless wireless power technology in market. And their vision is to make touchless wireless power a part of everyone's day-to-day lives. So sorry they could not attend, but I'd encourage you to check Wiggle out. We have a great afternoon planned to close the conference. As a reminder, at 5 p.m. we are going to have wine and cheese. And in between, we're going to have a great panel with Dinesh, Morris, Gordon, and Paul from Jam Systems to talk about the future of wireless power, which I know is a topic on all of our minds. And then, of course, we're going to have our kind of closing announcements and all of our awards for the conference. So let's take 15 minutes, come back here at 3, and then we'll wrap up Wireless Power Week. Thanks.
Okay, good idea. Yeah. Actually, it's pretty good.
Yes.
We can put it in the middle.
Yeah, let's do it during the panel.
Yeah, why not? It's good. It's a little marketing.
I'll unpack.
Yeah, I can do that. Just to change things up. You can just put them on.